Good morning, everyone! I am Janina Gusito.
I'm Michelle Ann Balayo.
And I'm Girly Ann Tenorio.
And I'm Roland Roda.
We are the BSED Math 2A
And
welcome to our video tutorial! Our topic for today is about less common multiple.
This section aims to relate the least common multiple to the greatest common factor for the product of two integers and apply the theorem on least common multiple in proving certain basic theorem.
Least common multiple or LCM. It is a smallest multiple which is common to given sets numbers. Greatest common divisor. The largest number that is a common divisor of a given set of numbers. Another equally important concept like the greatest common divisor. It is a least common multiple of a given integers. For example, given 12 and 18, then the multiples of 12, 24, 36, 48, 60, 72. Multiples of 18, 36, 54, 72. Then the set of common multiples of 12 and 18 is 36.
Definition 5.3.1. Given two integers a and b, then the least common multiple of a and b is the positive integer m, denoted by m is equals to LCM of a and b, satisfying the following conditions. A divides m and b divides m. If a divides n and b divides n, then m less than equal to n. The following are some immediate consequences of the definition. The GCD of a and b is less than equal to LCM of a and b. The LCM of a and b is equal to LCM of negative a and b is equal to LCM of a and negative b is equal to negative LCM of negative a and negative b. Theorem 5.3.1. For any integer a and b, then LCM of a and b is equal to m greater than 0 if and only if the following are satisfied. A divides m and b divides m. If a divides n and b divides n, then m divides n. Example Theorem 5.3.1. Given the multiple of a and b, which is 5 and 6, the 5 is equals to 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and so on and so forth. 6 is equals to 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, and so on. The LCM of 5 and 6 is equal to 30, and the GCD is 60. So the given A is equals to 5, B is equals to 6, M is equals to 30, N is equals to 60. Solution. A divides M and B divides M. Our A is 5 and our M is 30, so 5 divided by 30 is equals to 6. B divides M, our B is 6, our M is 30, so 6 divided by 30 is equals to 5. If A divides N and B divides N, then M divides N. Our A is equals to 5 and our N is equals to 60, so 5 divided by 60 is equals to 12. B divides N. Our B is equals to 6 and our N is equals to 60. 6 divided by 60 is equals to 10. M divides N. Our M is 30 and our N is 60. 30 divided by 60 is equals to 2. Our N is equals to 60.
Corollary 5.3.1. For any two given integers a and b, the LCM of a and b is equals to ab if the only if GCD of a and b is equals to 1. Example. Let a is equals to 5 and b is equals to 6. Solution. LCM of a and b is equals to ab. The value of a is equals to 5, then the value of b is equals to 6. is equals to 30. 5 times 6 is equals to 30. Since the GCD of 5 and 6 is equals to 1, 5 and 6 are relatively prime. Theorem 5.3.2. For positive integers a and b, the LCM of a and b is equals to ab over the GCD of a and b. Example, the LCM of 28 and 30, given a is equals to 28, b is equals to 30, and the GCD of a and b is 1. Solution. LCM of a and b is equals to ab over GCD of a and b. Then substitute the value of a and b. So our a is 28 and our b is 30 is equals to 28 times 30 over GCD of 28 and 30. So 28 times 30 is 840 is equals to 28 times 30 over 1. Then 840 is equals to 28 times 30 is 840 over 1. Then 840 is equals to 840.
Theorem 5.3.3. If a sub 1, a sub 2, to a sub n are non-zero integer, then the LCM of a sub 1, a sub 2, a sub n is equals to LCM of a sub 1, a sub n minus 1, a sub n. Example, let a sub 1 is equals to 4, a sub 2 is equals to 8, a sub 3 is equals to 16, a sub n is equals to 20. So get the LCM of a sub 1, a sub 2, and a sub 3, which is the LCM of a sub 1, a sub 2, and a sub 3 is 16. Then get the LCM of 16 and 20, which is 80.
And that's all for today's video. Thank you for watching!